Hello again. Welcome back to possibly the final edition of the Quarantine Tapes with Mr. Sharma. Today we're going to be looking at probability, but I wanted to start with a bit of a probability demonstration with the help of my good friend, Mr. Mike Rossi.
Hi, grade 8s.
So, Mr. Rossi is going to help me by shuffling up these cards here as best he can. I want to do a bit of a magic trick here. I want you to know that there's no funny business going on here first. Sufficiently shuffled, sir? I just want to make sure that I want you to know that I didn't mess these cards up or anything. It's a regular deck of cards here. No funny business going on whatsoever.
It looks like 52.
Okay, perfect. Now I'm going to go ahead and shuffle these up just to again make sure it's completely mixed. I'll get Mr. Rossi to cut it wherever he likes. Okay, thank you. Now I'm going to use Mr. Rossi's name here to help me figure out what a random card on this side of the deck is going to be. So his name is Mike, so let's spell it out. M-I-K-E. The 10 of spades. I'm going to use this card and its magical powers to help me figure out what the fourth card in the other deck is going to be. And it feels like it's going to be a 6. He's wearing a lot of black today, so I'm going to go with the 6 of spades. So let's try it out again. M-I-K-E.
Wow!
Pretty amazing, right? What if I told you that was actually a complete guess? What would the probability be of me actually being able to guess the right card out of an entire full deck of 52 cards? How do we figure out that percentage?
How, Mr. Sharma?
Well, I'm glad you asked. See, probability is all about putting your desired outcome as a fraction of all total outcomes. So we're going to make these a fraction. On the top part of the fraction, the numerator, is desired outcomes. That's your numerator. Your denominator is going to be total possible outcomes. Total possible outcomes. So how many desired outcomes were there in this demonstration we did here? There's only one. There's only one 6 of spades in the entire deck. One desired outcome. How many total possible outcomes were there? Everybody knows there's 52 cards in a regular deck of cards. So 52 was the total possible outcomes. So there was a 1 in 52 chance, without the aid of magic, that I could guess what exact card was on that side of the deck. Now, 1 in 52 is kind of a mouthful to say, and it's not really that relatable for us. So we're going to go ahead and turn this into a percent. Do you remember how to do that? You should. All we have to do is divide the numerator by the denominator and then multiply it by 100. So 1 divided by 52 is 0.0192. That's our decimal. You know by now we have to times that by 100 to get 1.92. There was a 1.92% chance of me guessing the single card correctly. Let's look at some other examples. Okay, so, well, one similar to the one we just did. What is the probability of someone drawing an ace from a deck of cards? How many aces are there in a deck of cards? Yes?
I believe there's 4.
There are 4 aces, correct. I just want to rewrite the base fraction for us to follow here. On the top was total desired, and the bottom is all total possible. So total desired, there's not just one ace, there are, like Mr. Rossi said, 4 total aces in a deck of cards. So we have 4 desired outcomes here. How many total possible outcomes are there? There are 52 possible outcomes in a deck of cards. We have our fraction now. We want this as a percent. 4 divided by 52 is 0.0769. We're going to times that by 100, of course, to get 7.69%. There is a 7.69% chance of someone drawing an ace from a deck of cards. So really simply, like, you'll probably have a lot of dice questions and probability questions this year and next year. So the chance of you rolling a 4 on a dice, there's only 1 4 on a dice. There's 6 total sides. We only have 1 chance out of 6. Let's see if we get it. No, we didn't get it. But 1 out of 6 times 100 is 16.67% chance. So the probability of rolling a 4 would be 16.67% chance of you actually having success in that event. What if we have multiple events? We want to find the probability of you doing one thing and then doing another. The probability of someone drawing a spade from a deck of cards and then flipping a heads on a regular coin. We have 2 events here. We have to draw the card, then we have to flip the coin. So here's how that works. The probability of someone drawing a spade from a deck of cards. How many spades are there in a deck of cards? There are 13. There are 52 total cards. So that's our first event. Because we have 2 events here, we have to make a separate fraction, and we're then going to multiply these numbers together. We want to flip a heads on a regular coin. How many desired outcomes, how many heads are there on a coin? Obviously there's only 1. So that is our top part of the fraction, our numerator. Total possible outcomes, how many sides are there on a coin? There's 2 sides. So 1/2 is our fraction. We now have to multiply these 2 fractions together because there are 2 events. 13 times 1 is 13. 52 times 2 is 104. Convert this into a percent. The percent chance of us drawing a spade from a deck of cards and then flipping a coin, which I don't have right now, and having it land on heads is 12.5%. Pretty decent odds. I think we just have one more to go through here. Oh yes, Mr. Holbrook. Mr. Holbrook has a pretty wide variety of musical taste. He is listening to a playlist he made on Spotify. He has time to listen to 3 songs at random before class starts. On this playlist, he has 24 rap songs. He has 13 Bollywood songs. He has 10 country songs. He has 22 classical songs, and he has 39 songs from the High School Musical movies. What is the probability that the songs that come up are first Bollywood, second rap, and finally country? We want to have that exact sequence of songs randomly come up on Spotify. So because there were 3 events, we're going to have 3 fractions to multiply. What is the probability first of drawing a Bollywood song? Because that's the first option that comes up. There are 13 Bollywood songs. What's our total possible outcome? What's our denominator going to be? It's going to be the total amount of songs on this playlist. 24 plus 13 plus 10 plus 22 plus 39. 24 plus 13 plus 10 plus 22 plus 39 is 108. That's how many songs are on the playlist. Next up, the probability that a rap song comes. It says here that there are 24 rap songs, so he has 24 chances to draw a rap song out of 108 songs still on that playlist. Finally, a country song. How many country songs does Mr. Holbrook has? He has 10. Out of, again, 108 total songs on the playlist. We then are going to have to multiply all these together. You'll remember, I should have mentioned this earlier, multiplying fractions, numerator times numerator, denominator times denominator. Remember that? So we're going to multiply all these numerators together. 13 times 24 times 10 is 3,120. And then our denominator is going to be a pretty big one. 108 times 108 times 108 is, oh my gosh, 1,259,712. We've got our probability fraction. It's no use to us right now. We want it as a percent. So divide your top by your bottom. 3,120 divided by 259,712 equals a pretty small number. Turn it into a percent by timing it by 100. 0.25. So the probability of Mr. Holbrook sitting in his classroom choosing 3 songs at random, the probability of it being a Bollywood song, then a rap song, then a country song on his playlist is 0.25%. Less than a 1% chance of actually happening. Crazy, right? So things to remember, your fraction is always going to be total desired outcomes over total possible outcomes. The chance of you flipping a coin is 1 out of 2 for the side that you want, heads or tails. The chance of you drawing a certain suit is going to be 1 out of 4 in a deck of cards. This is 4 suits. And that about covers it for today. Check out that workbook homework, and there will be an assignment coming later this week. I want to say Thursday. Hope you guys are all well. See you later.